Hello, my name's David Runciman, and this is Past, Present, Future. Today we're doing something a little bit different. We're going into the much deeper past, and we are speculating about the unknown future. We're talking about space, asteroids, and extraterrestrial life. I'm talking with Chris Lintott, the Professor of Astrophysics at Oxford and also one of the co-presenters of the BBC Sky at Night, and Tom Stevenson, who is a contributing editor at the LRB. And as we'll see, they've both recently written in the LRB about asteroids. That's where we're going to start. And apologies for my somewhat croaky voice this week. It'll be gone soon. Past, Present, Future is brought to you in partnership with the London Review of Books. If you've been enjoying the subjects we've been talking about on PPF, we think you will really enjoy the LRB. And listeners can subscribe for just £1 an issue for the first 3 months at lrb.me/ppf. Just go to lrb.me/ppf. So, Chris, Tom, maybe we could start with something that you both have written about in the LRB as a way into talking about asteroids and then a broader discussion about how we should think about threats from space. But you've both written about something that happened in September last year. Maybe, Chris, you could start with this. Just describe what it was and why it mattered. How did the LRB end up publishing 2 pieces about this maybe somewhat obscure event, or maybe one of the most significant things that's ever happened?
Well, I can help you with the astronomy. I think understanding the LRB editorial process is way harder than understanding the cosmos. So let's start there. This was a little mission called the Double Asteroid Redirection Test, or rather neatly DART, which was a NASA mission to deliberately crash a spacecraft, which I think I described as being about the size of a golf cart, into a small and unsuspecting asteroid. The target was a pair of asteroids, the larger one, Didymos, and then a small asteroid called Dimorphos. The reason to want to do this is that we know that there are many such objects, some small, some rather larger, that can hit the Earth. And we know over the long history of recorded time, we see asteroids hitting the Earth. We know that they did things to the dinosaurs and so on. But we've never really had a good form of defense. And so this was a demonstration of our ability to hit an asteroid and to try and deflect it. One of the interesting things about this is that the physics feels like it should be simple. This is basically just snooker. You're hitting one object into another. If you know how fast the object coming in is going and how hard you hit, then you should be able to calculate how fast the thing is going to fly off in the opposite direction. But asteroids aren't really solid bodies, it turns out. They're more like, if you're imagining a rock, stop it, what you should think of is like what you get when you scoop up a bucket of material from a pebbly beach. These are rubble piles. They're not really solid at all. And so you smack something into one of these, you get a cloud of dust thrown up, which was observed from the Earth when the spacecraft hit. We're still tracking it now, almost a year later, and that changes the physics. So this was an attempt to see how hard we'd have to hit the asteroid to make a deflection such that we could prevent something from hitting the Earth if we found something that might hit in 20 or 30 or 40 years' time. The test was a success. We had a room full of scientists and engineers celebrating as their spacecraft destroyed itself, which is an unusual and slightly strange thing in the field. Normally you want your spacecraft to survive. And then just a few days later, observations of the asteroid showed that its orbit had been changed significantly. And so we managed to give it a proper wallop and make a difference.
And I want to bring Tom in a second because there's a question about what this says about human beings as well as what it says about asteroids. But can you just give us a sense of the scale of it? So this was a smaller asteroid orbiting a larger one, but how did those two stand relative to the one that took out the dinosaurs, say, or something that could be Earth-threatening? These were pretty small, right?
They were in the slightly strange language used by people who think about these things. They were sort of city killer asteroids. So if one of these landed on us, then it landed on London, then you wouldn't want to be anywhere in the home counties. That's that sort of range. So the bigger of the two is a few 100 meters across. The smaller of them, I said, was the size of a cricket Actually, I said in the LRB it was the size of a cricket field, but it's actually a cricket pitch, of course. So we should get that right. So these are small asteroids. There are lots of these. To give you a sense of them, we have about 600,000 asteroids in the catalogue, most of which are about this size. About 30 to 40,000 of those cross the Earth's orbit and might hit us. So this is the detritus of the solar system. Space and the asteroid belt is filled with these things. There are probably a few million things this size, and we're just getting to the point where we can track them and say something about which of them might pose a threat to Earth.
And how often do they hit, roughly?
So something the size of Didymus hits roughly every few hundred years or something like that. So we get a significant asteroid fall somewhere on the Earth every year. Dust, smaller particles are falling in all the time, but we get something like this every few hundred years. Most of Earth is, of course, water, so most of the time they do no damage and they don't cause any problems. But if we did see one of these larger things heading towards a populated area, then we may have trouble.
So, Tom, you'd think it would be a no-brainer that this was a good thing, that human beings develop the technological capacity to intervene in space so that when we are threatened with a Earth-ending object, we can deflect it. Everything about that sounds like it makes sense. But you wrote about what I think is called the Sagan-Ostro paradox. So it's a paper that was written about 20 years ago by Carl Sagan and a guy called Ostro, Carl Sagan better known, but which raised the question, which seems to me completely fundamental for thinking about space, which is a lot of this depends on what human beings do with the technology that they develop. And the point that they make is these asteroids, there's a small, very small, but real chance that they could hit and do terrible damage, and therefore we need to deal with that. But just as we can deflect them off us, we can also redirect them towards us, which might sound like a crazy thing to want to do. Which human beings would think it was a good idea to take asteroids that weren't going to hit Earth and direct them towards Earth? But given what we know about human beings and what we know about what human beings do with the technology they develop, their point is, in some ways, that's the bigger risk.
Yes, I think the argument in favor of developing asteroid deflection technology, things like DART, has the great advantage that it's intuitive and simple. There are lots of asteroids, they've hit the Earth before. In prehistory, asteroid strikes have caused mass extinctions, notably the KT extinction, but also others, perhaps even the PT extinction. So, the idea that a technologically advanced society should try to do something about that is superficially reasonable. By contrast, the argument for skepticism of deflection technology, or even countermanding it presents as a paradox. So in the 1990s, Carl Sagan and Stephen Ostro pointed out that just developing the ability to deflect asteroids counterintuitively might actually increase the chance of an asteroid striking the Earth. Why? Because if you can change its course, you could just as easily change its course towards the Earth as away from it. It sounds insane, but the history of superpower competition, which, as we'll probably discuss, is somewhat bound up with space technology, contains a lot of crackpot schemes and also lots of sort of insanity. And it need not be a scheme. What if the leadership of a powerful state with very advanced space technology were to be overtaken by a messianic belief system, for example, or if a benign deflection intended to reduce the risk to the Earth of an asteroid collision simply went badly wrong? That's the argument that Sagan and Ostro put forward. In my experience, talking about this, most people don't find the Sagan-Ostro paradox to be terribly convincing in its own terms. They often find the idea that an intentional asteroid deflection towards the Earth is implausible or fanciful, and then they forget about accidental maldeflection. But I think the reason for the relevance of the paradox lies in the fact that it demonstrates how different thinking about space technology was in the recent past. There was a sort of a much more pervasive skepticism towards the proximity between space and military technology. And there was also a very different sensibility. It makes me think, for example, of Norman Mailer in A Fire on the Moon, saying that there's a danger that space might be a grand avenue for the new totalitarianism. Some of that sort of strikes us as strange now, but I think it's sort of worthy of contemplation nonetheless.
And Chris, it raises, in a sense, a fundamental question, which is there is a view that thinking about some threat from space ought to be the thing that galvanizes humanity to put aside its petty differences. You know, it's the Hollywood vision, right? And it tends to be under US leadership. And maybe we'll come on to whether that's still plausible or not. But the idea that there is something which is by way of a cosmic threat, which makes human politics seem petty and irrelevant. The other view, and there is also a Hollywood version of it, which is, you know, the Don't Look Up version, which is actually all of our experience and all of the ways in which we try to intervene or not intervene in space is a manifestation of those petty differences, of who we are. And as it were, it's just an extension of that. Do we fall too easily into the first view? There's a sort of techno version of the first view, which is this transcends human limitations and the limitations of human politics. What I found compelling about the Sagan-Ostro paradox was it highlights the fact that it may be naive to think that anything transcends the pettiness of human politics.
I think if we do find ourselves voyaging into the cosmos or exploring the solar system, then we're going to find ourselves wherever we end up. And the history of societies expanding and encountering strange new situations, and who knows, maybe even alien beings out there, isn't a whitewashed happy one here on Earth. So I think that's right. It's very easy to think about these things as if technology will triumph and we don't have to worry about the rest. I think there's two aspects of the paradox in this situation in particular that I think are interesting. One is that I think a lot of the calm and reassurance comes from our lack of ability to predict where an asteroid might hit. So we're capable of saying, using telescopes on the ground to discover asteroids and to plot their path for the next century or so. And so we know that we're pretty safe of anything really large as the things that did for the dinosaurs. The biggest threat is something called Bennu, which has a 1 in 3,000 chance at the minute of hitting late in this millennium, and will probably not hit, and we're keeping an eye on it, and that's fine. But we certainly can't predict, even if we knew something was on a trajectory to impact the Earth, we're not at the point where we could predict whether it's going to come down in the Pacific Ocean or the middle of Rome or whatever. And so if you are talking about targeting or deliberately aiming an asteroid at your enemy, you have to make the intervention 30 years in advance, and you're taking pot luck. So it's more of the scenario that's part of the plot of the books and the TV series The Expanse, where a terrorist act is to lob asteroids towards the Earth and not care where they're going to hit. So it's less about superpowers clashing and more about wanton destruction, which is, of course, part of the human experience. The other thing that's odd about this, and it's another illustration of how we have to think differently when we think about space, is that we can't predict where these things are going to be in more than 100 years' time. Even if we have tracked an asteroid for the last 100 years, I can't tell you where it's going to be in 200 years' time, because subtle effects like the gravitational pull of Jupiter or Saturn, or the effect of sunlight on the asteroid, which adds up to something beautifully called the Yorp effect, which is rather nice, means that chaos takes over and our ability to predict where things are going to be drops off. And what that means is that we could very well make an accidental intervention if we get to the point where, for other reasons, perhaps for mining or perhaps for purposes of building spacecraft, we start to remove material from asteroids or shift their orbits to make them more useful to us. You could easily accidentally, without ever knowing it, cause something to collide with the Earth 100, 200, 300 years hence. So there's a sort of accidental version of this as well. Now, you might say, who cares? You know, I didn't know that was going to happen. I can hardly be held responsible. But there is something different. This is almost an asteroid trolley problem of something different between an asteroid hitting us accidentally and because, you know, Lintott Enterprises went up and extracted half of the water from a particular asteroid.
And that second scenario is not entirely fanciful, right? Asteroids are potentially sources of important minerals, and in that respect, they could well be extensions of both economic and political competition on Earth.
Yeah, you get rare earths and things, and there are some interesting economics. There are platinum-rich asteroids, for example, but there's a lovely paper which showed that if you bought one of those to Earth, you'd immediately crash the value of platinum, so it would instantly become not worth doing. So the economics of asteroid mining are interesting, but it's undoubtedly true that if access to them was easy and cheap, then there are things up there that it would make sense to mine.
Tom, what's your sense now of the Hollywood scenario that were we to face one of these planet-threatening events, naturally US leadership would come to the fore. So the test that we were talking about was a NASA test. But the deeply cynical Hollywood version of this from a couple of years ago, Don't Look Up, was a parody of contemporary US politics. The idea that basically the world could be about to end and Fox News would still be sticking to its talking points to distract us. The 1990s versions, which are the more euphoric post-Cold War versions, and Independence Day is part of that too, which is in the end, when threatened, American pluck and daring do would win out. The difference between then and now is that US leadership in this sphere, but more generally, US global leadership, is not what it was in the 1990s, and there is a rival, China.
Sure, absolutely. And I think the context is that we see something like the beginnings of national space competition beginning to reemerge. So you can already find, for example, people like Christopher Ford, who's quite a senior official at the US State Department, talking about Russian and Chinese efforts to weaponize the space domain. This sort of rhetoric has come back. And I think that points to two things. One, a certain anxiety about what you're saying, about to what extent the sort of hard power element of the American order is still intact or preponderant. And also this idea that you might again see other states might be in leadership positions, at least in the future. The only way I think you can sort of answer that question for now is to look at what programs there are and who's actually conducting them. And it's certainly undeniable that China is pursuing its own space program with increasing elan. That said, in the US context, it is still sort of the US military that's very prominent. I mean, if you look at who's developing advanced communication systems between satellites, it's the US Army. Who runs the space-enabled effects for military engagements programs, DARPA. Space debris telescopes, systems still, very much developed in the military sphere and then transferred over. NASA itself has plenty of formal cooperation agreements with the Department of Defense and with the US Space Force, relatively recently founded. And these were not signed during the Cold War, but in the last couple of years. DART, the recent asteroid deflection test, was launched from a US Space Force base. Where else would it be launched from? That sort of thread between masters of the universe and masters of war, as it were, has always been there, and it's easy to see it coming back to the fore. We already see, US generals, technophiliac generals at least, will often talk about foreseeable wars of the future being won or lost in space. That sort of thing is coming back. So all of those anxieties, I think, about Earth's power and space, the combination between the two, are there and becoming more and more prominent.
Yeah, so it's interesting in this context to think about the International Space Station, I think, which was, the big focus of the previous generation of American and European and Japanese and Russian crewed exploration of space. But the space station's an interesting thing because a huge amount of money and effort went into building it for no other real purpose other than that it was nice that it exists. And in fact, if you look at the descriptions of it, particularly by American politicians, through the 90s and into the 2000s, the reason they give for the International Space Station existing is that because it is international, that it's a symbol of collaboration, which is reasonably effective. It's interesting that the national cultures persist up there, so the different modules supplied by different agencies have their own feel and so on, and I'm told, the Japanese have the best food, the Americans have the best kit, the Russians have a nice pastel-coloured module that you can go and hang out in, and the Europeans took a coffee maker up. So, Tim Peake, of course, the British astronaut who went up, took the only bacon sandwich in space, so we've contributed too. But the fact that that was seen as an international endeavour, and almost that being the motivation for it existing, there are questions about whether that will continue while we've still got Russian astronauts up there. Cooperation with Roscosmos is clearly, which is a branch of the Russian military complex, is deeply difficult, of course. In the next step, we seem to have this race to go back to the moon. The Chinese have their own plans, and it's very, very difficult from the outside to put a timeline on those plans, but we can see that they're conducting a series of so far uncrewed missions to the moon that are stepping stones towards getting boots on the ground. And America has a similar plan, which comes under the heading of Artemis. They've been very explicitly using this as space diplomacy. So there's a set of things called the Artemis Accords, which are an agreement to collaborate on missions to the moon, which many of the European nations, including the UK, have signed. There was recently much fanfare that India had signed the Artemis Accords, which was seen almost as India picking sides in this very Cold War-like way of competing teams trying to get back to the moon. And again, this is being driven, I think, by the competition. There isn't, as ever with these things, if you want to spend money to understand the moon or to do the science that we can do up there, you would send robotic probes. You send people because you want a flag and the symbolism, though they can do useful things once they're there. And so we are seeing this competition for resources and this attempt to use it as a diplomatic tool.
Tom, you wrote in a piece where you quoted Lyndon Johnson in 1958, so right at the dawn of the space race, and when Johnson was Master of the Senate, before he was en route to becoming president, in which he said, which I guess was the conventional wisdom then, I quote, "Control of space means control of the world." But the example that he gave was the people who control space can control the climate. That was what and this is a pre-climate change vision of it. It was more a sort of James Bond villain vision of it, that they could cool the atmosphere or whatever it is. They could redirect the Gulf Stream. But as it were, we're on the cusp of that as well, at least. So both as a planetary threat, the great threat that we face is climate, but also as an extension of geopolitics, competition for control of aspects of the climate you can completely imagine, not in a sort of paradoxical way, but in a straightforward geopolitical way, becoming central to international competition. I mean, is there at least potentially a step change coming there too?
I think there very well could be. I mean, at the beginning this idea that space represented a strategic dimension in terms of being the ultimate high ground was very prominent. I mean, even pretty much as a direct response to Sputnik, you saw the US national security establishment go into a frenzy, and an enormous amount of productive work went into that, but all very much in the Cold War superpower competition framework. Obviously, with the demise of the Soviet Union, the mood very much changed, and we haven't been for a very long time in a position where you have Werner von Braun on television discussing the prospect of nuclear-powered space stations with spacecraft going up and down that need to be controlled by the United States and so on. It simply sounds bizarre to us today. And yet we seem to sort of be edging back towards, in many ways, that kind of new Cold War rhetoric in other areas. There's increasing concern about nuclear competition between the US and China, with China modernizing its nuclear arsenal beyond basic second strike capability, and the US also involved in a generational nuclear weapons update itself. So that, which has always been very much tied in with space technology historically, has been sort of going on in the background, and the prospect of a sort of a more unstable, even tripolar nuclear order would, I think, force a completely different kind of thinking about space and military technology, a different mood, or a different mode, perhaps better to say, in sort of addressing these questions. So that's something that I think is probably due a revival.
And Chris, do you see this intersecting with both the threat and the politics of climate change? I mean, are we on the cusp of that as a driver of some of what we might be doing in near space?
Well, I was thinking about this in the context of people writing about geoengineering, of technological fixes to climate change that involve us deliberately altering the atmosphere or blocking sunlight or whatever. And there is this contested space where it's not clear who has the authority to approve such projects. There have been a few rumblings where, university studies have been extremely controversial, even though they're on paper studies, because it's felt that one shouldn't even think about these things. There have been a couple of private companies who've done very small scale tests of the kinds of things that one might do, and that's controversial. So you can imagine a world in which, the Chinese would certainly be technologically capable of launching a mission that puts a shield to reduce the amount of sunlight that hits the Earth's atmosphere, which would cause changes to the climate. So that's not technologically difficult compared to some of the things that we're doing in space, like trying to hit asteroids or fly large telescopes or so on. So I think there is connection. I think one thing that we haven't talked about is the changing use to which low Earth orbit in particular, the near space as it's often called, is being used. So the number of satellites and the number of things in those orbits have dramatically increased just in the last few years, primarily because of sort of rush by private companies, SpaceX, but coming soon Amazon, a company called OneWeb that the UK government has strongly invested in, to launch fleets of commercial communication satellites. Now, those are There are currently something like 5,000 active satellites in low Earth orbit. That's more than doubled in the last 3 or 4 years. There are permissions on paper for those companies between them to launch more than 500,000, something that would completely change the nature of the space. The systems of how satellites navigate around each other, in particular how defunct satellites get removed so that you don't get space junk, a problem which, by the way, is made much worse by tests of destroying satellites, which several nations have carried out, producing large numbers of bits of material that have the chance to hit other working satellites. And that's it feels like a land grab, because those companies are trying to grab as much of that space as they can, I think, before regulation catches up with them. When you ask the question of why are they doing that, perhaps even if you ask the question, why are SpaceX being permitted to do this, to grab a common resource and commercialize it, the real reason for those networks is, I suspect, military. There's clearly a need for low latency communication satellites that you can bounce things off and communicate on battlefields with drones and so on. And so we saw this a bit in the rhetoric about whether Europe needed its own GPS system and whether Britain should be part of that or have our own post-Brexit. So even when the companies are explicitly commercial, the stated motivations, or at least the PR motivations, are commercial. I was just in New Zealand, and the airports are covered in adverts for Elon Musk's Starlink broadband service because it works in rural New Zealand. There is a military dimension to that, which is driving the design and the implementation of those networks.
And Tom, in a way, SpaceX, you've got the three things going on that we sort of started with. On the one hand, you've got space as something that can be exploited commercially. Second, you've got space as the new site for superpower conflict and an extension of geopolitics. And then you also have the rhetoric of SpaceX, or maybe it's the rhetoric of Musk himself, which is this is a sort of civilization-saving interplanetary mission because there has to be a planet B because we're screwing up this one. You've got these three levels to it. There are different ways in which one can be cynical about it, as where you can be cynical about the commercial stuff and see behind it the military. But you can also be deeply cynical about this is going to save us all stuff. Where should we place our cynicism here? Should we be completely cynical about this is actually about rescuing the human race? Or civilization? Musk loves to talk about civilization. It's a civilization rescue project.
Well, I think there's a very interesting tension there, which starts really with the idea that when we imagine space technologies, I think most of us have images in our minds of sort of interplanetary exploration, one way or another. And I think the PR or marketing side to almost all private space endeavors builds very heavily on that, while at the same time the practical effects are for the most part focused on what Chris said, the orbital infrastructure, which you can argue about how much of it is really in space at all. We don't have a very firm definition of where the boundary between sort of Earth and space begins and ends. I mean, we have the Kármán line, but Kármán himself never really considered that to be, sort of an absolute boundary. Beyond this is space or not. It was more jurisdictional. The orbital infrastructure in terms of satellites and so on is not all that far up. You're talking about, in some cases, just less than 100 kilometers or so. But then this idea of travel to other planetary systems or stellar systems is, of course, the exciting part. And that's what goes along, I think, with saving civilization, saving or escaping the Earth's confines. And I think there's always been something sort of quite particularly American about that vision. Jim Oberg, for example, opened his study of space power with a comparison between humanity expanding into space and the building of the National Road West in the 19th century in the United States. And he said, detractors who opposed the road thought of it as a folly into the desolate West, in the same sense that detractors of space exploration might think of, there's nothing up there, it's just desolate and so on. I think that probably the biggest problem, the best place to put your skepticism, if you're going to put it somewhere, is that there really is nowhere more valuable or more worth tussling over than the Earth. There is in fact, no equivalent of America to Europe that we can find. That is finding somewhere sort of just as or even more rich and fertile than the Earth itself. So we can have a race for a moon base, and we are having one. Well, the moon has oxygen, silicon, magnesium, iron, etc. May have water ice, but it's also dusty, sun-beaten, very low gravity, and dark for 2 weeks of every month. And we know how conditions affect these things. We know how difficult it is. We have an entire continent on Earth that is completely unsettled, Antarctica, at least with permanent settlement, and so isolated from the rest of the world that it sort of barely registers. Even the US military barely bothers with it. And then I think, so even if we are able to stretch our minds beyond that and say, okay, we find a way to sort of transcend all of those problems, and it's somehow successful. We're able to sort of, humanity is able to escape and, repopulate the galaxy in the Musk vision. Is it necessarily clear that that would be a positive development? In some ways, certainly yes. But, we don't see human societies getting on all that well on Earth, even lowlanders and highlanders. Why would we expect human societies living on different planets to get along with such different interests? And the prospect of sort of rivalrous relations, not just between nations, but between worlds, is something that probably gives us pause. So you could say perhaps it's fortunate that dreams of species irradiation or of humans frolicking in the methane snows of Titan remain, for now at least, just dreams.
Yeah, but now I want to go to Titan, which I did anyway. But I mean, the best thing about Titan is the rain in Titan, which is composed of methane, as you say. Raindrops are the size of tennis balls, and they fall slowly enough that you could dodge them. And I think there's something about this just appeals to me. I think that would be fun. But you're right, of course, that, I mean, fundamental to everything you've just said is that even if you have wild and unrealistic goals for the next few millennia, there's never going to be a future where most of humanity doesn't live on Earth and thus depend on Earth. And this is often missed out, particularly in Musk's vision of him and his brave group of people on Mars. Yes, all right, if a very, very large asteroid or something happened to Earth, then there'd be a few people clinging on. But that's not a way to establish a civilization. You have to be many tens of thousands of years in the future to imagine anything that gets us away from Earth. There is a slight contrast, I think, with talking about the ideas of the billionaires who are funding this to some extent. But Bezos is interesting. He has his Blue Origin company that have just been given a large contract for a second option for NASA's return to the moon, which heavily depends on the efforts of SpaceX and now Blue Origin. But he talks about almost as space as a way to preserve a slightly odd utopian vision of Earth. He talks about moving manufacturing off Earth as if, cities and factories are blights on the Earth's surface, and then we can have forests to frolic in here. So it's almost this return to nature vision that goes back. There's a long strand of this in particularly sci-fi in the 1950s has a lot of the sort of utopian planet enabled by high technology, and that is a slightly different vision, I think. I should say, though, that I think inspiration is changing. And one of the arguments I've made in my career as a communicator about science and about astronomy is that astronomy and thinking about space is a gateway drug to thinking about other forms of science and other forms of learning for kids and adults. There is something compelling about images from the Hubble Space Telescope or that view from Mars or thinking about those things. It used to be the case that the most compelling stories were those about people doing things, Neil Armstrong and Buzz Aldrin on the lunar surface, or tales of the space station and whatever else. I find that's shifting a bit. That as it's been colonized as space exploration itself has been colonized by the billionaire class, it's become seen as a frivolous thing that rich people do. It's Richard Branson's tourists, and it's Musk launching a car for no reason, and that doesn't impress. Whereas we still get excited about images of Jupiter from the Juno spacecraft, which are stunning, or the things we're getting back from the JWST, the new European, Canadian, American space telescope that's showing us images of the distant universe. So I think there is an inspirational value to be got from space, but perhaps it's less a story of exploration and more a story about acknowledging and viewing the cosmos that's up there, maybe even beyond the solar system.
So to finish, could I ask the largest one of all, or the largest version of the question that we started with, which is this something that transcends our human imaginations, and should we think about this as separate from our petty concerns, or should we filter it through our petty concerns? And that's the question of how we should think about the possibility of life outside of this planet and our search for it and how we should search for it. And these arguments have been going on forever, or not forever, but certainly in the modern age, what it would mean for us to try to communicate beyond our own species. And some of the arguments are ones that see this inevitably as this kind of extension of international relations. The thought that it's extraordinarily naive to send signals out there saying, here we are, because we know that if we did that, as it were, on Earth, as potentially relatively defenseless creatures, signaling to the predators, this is where we are in the woods, is a sort of suicidal act. But that's to assume that whatever we encounter or however we encounter it would be an extension of what we're familiar with. These questions are impossible to answer, but how do we do it? Should we think of this as an extension of geopolitical international relations, or should we think of this as something which is beyond our ability to imagine, and therefore we should just be deeply, profoundly curious?
I'm fascinated to hear your thoughts, Tom, but maybe let me just say a few things, because these questions have been asked for a long time, certainly since the 60s and before that in literature. But there are a few facts that are recent in this. The first thing is that the great triumph of astronomy of the 21st century so far is that we now know that planets are common. So if you go outside and look up at a night sky, almost every star we now know has planets going around it. And planets that are like the Earth, for whatever set of criteria you want to write down, but roughly rocky planets with atmospheres like our own and some source of water at the right distance from the star, that they're about this temperature. They're very common too. It's difficult to give an exact estimate, but maybe 100 billion of them exist in the Milky Way galaxy, something like that. That number's wrong, but it's not wrong by more than a factor of 10. So we now know there's an extraordinary diversity of worlds out there. The second thing to say is that we see no evidence of life yet amongst the stars. So if there is life there, and if there is intelligent life there, it's not the galaxy-spanning, star-manipulating, dramatic civilization that one might expect from science fiction. That there may be abundant life out there and abundant intelligent life out there, but it's not whizzing around between the stars and changing the galaxy. We'd see it if it was. And then the third thing is that we have, of course, been broadcasting into space since the early 20th century. We're building a telescope now called the Square Kilometre Array, which will be capable of picking up airport radar on probably the nearest 200 planets. So if we've reached that stage, one would think that civilizations out there close enough to have received our signals will know that we're here. In particular, the most powerful deliberate signal ever sent into space was an advert for Doritos, which was transmitted from a radar station in northern Norway about 10 years ago. So they know we're here if they're out there. So with that context, does any of that help us inform what we should say about messaging, or who should message to the cosmos?
Yeah, I think it's a question which is, of course, impossible to have much confidence over. I mean, in his book, Daniel Dudonay says that the most important discovery of space-age astronomy is that the Earth is this minuscule oasis of flourishing life in an unfathomable, desolate wilderness. But the fact is that we just can't know that yet, at least not enough to call that a discovery that we can have any confidence in. Ultimately, I think it is impossible for us, at least, to escape our own imaginations when trying to deal with these things. And there's something about space, incidentally, that it seems to me sort of always combines the futuristic and the archaic. So many of our space and sort of normally the highest of high-tech space technological systems have ended up having lithic names. They're called smart rocks or pebbles or Excalibur or something like that, which sort of, we seem to have that strange combination in our minds that there's something both almost primal and at the same time Promethean going on at the same time. So, I mean, in terms of actually being able to go beyond that and make contact with other life, of course, I don't sort of want to do the science fiction elements down, because science fiction has not a terrible track record in predicting technological inventions. You can find H.G. Wells predicted tanks. Science fiction predicted the importance of geosynchronous orbit well before it was actually achieved. So sort of the best answers we have probably are the science fiction answers rather than the international affairs models answers, I would say. And of course, we've probably all alluded to it one way or another already. But I mean, someone like Liu Cixin's answer of the dark forest is very compelling and very powerful to think about, and certainly it gives one pause. But as Chris says, we've already sort of made some of these decisions in advance. If we are in a dark forest, we've already signaled our location in many respects. And as to who should answer, it will end up being a matter of terrestrial power whenever that moment arises, should it arise.
I recently watched Tucker Carlson interview Elon Musk about whether the US government is covering up the already known existence of extraterrestrial life. It's a slightly bizarre interview. And obviously Tucker Carlson is prone to think that, if there might be a cover-up, there will be a cover-up. And Elon Musk in this interview is the voice of reason. And he gives two responses, one of which seems to me not very convincing, the other more convincing. So the not convincing one is Elon Musk says, I know more about space than anyone else in the world. So if anyone would know, I would know. That seemed to me a less good answer. The better answer was, given what we know about the US military, and their primary concern is to raise their budget. That is the politics of the militarization of the American state. Do you think they would forego the opportunity to raise their budget by concealing this? The second one seemed to me like a good argument.
There's also the practicality of the fact that we live on a rock that turns once a day. So I'm always amused by efforts to suggest that astronomers are keeping any of this quiet, because if I see something odd, say using a telescope in the Canary Islands, I have to tell the Americans about it long before I've understood what it is or whether it's interesting, because they have to pick up monitoring as the Earth turns, and they have to tell or people in Chile will then have to tell Australians or people in Asia. So long before anyone had come to a consensus that a signal from space was artificial, every astronomer on the planet would know about it. And we're terrible at keeping secrets. We've had a couple of big news stories this week that are broken, and everyone in this building knew exactly what was coming out. It's to do with gravitational waves and the rippling of space-time, which I won't distract us with right now, but it's very exciting to people like us.
And Chris, I should say, because people can't see, the building that you're referring to is the University of Oxford Astrophysics building?
Yes, I mean the Dennis Wilkinson building, which is home of Astro in Oxford. Yes, that's right. Sorry, I should have explained.
Not just as it were your home or something like that.
That's true. The topic of conversation there too.
That discovery was picked up in China, was it not?
Well, interestingly, the discovery was by international collaboration of networks in America, Europe, India, Australia, and New Zealand, and a new Chinese telescope called FAST, which is hugely powerful. And the Chinese published their own results, which they claim provide a stronger detection of what we were looking for than any of these other efforts in a much shorter time. And the Chinese claim is which is being interrogated and considered now, but they just claim, well, we've got the best telescope. And in fact, the paper says, even if this result isn't quite there yet, we've got the best telescope, so in a couple of years we'll be way ahead of everyone else. And so it's another example of, in this case, chasing fundamental physics, but of collaboration. But I did want to come back briefly to this idea of alien signals out there. I spend a lot of my time talking to people who do SETI. I have an interest in finding the unusual. So the search for extraterrestrial intelligence is sort of the byproduct of my research, because I find unusual astronomical things, and maybe one day one of them will turn out to be something alien. But a discussion that has happened in SETI circles for many decades is, the profound effects of the reception of a deliberate signal. So let's say we pick up something pulsing prime numbers at us or something, evidence of intelligence in the cosmos. And amongst people who've spent their lives working on this stuff, it's seen that this would be, the typical strapline is this would be the biggest news story of the century. I've come to think that I think this would be in the news. It would probably lead the 6 o'clock news for a day. But I think unless the message is we're coming to get you, I'm interested in your views. How profound a moment would that be, do you think? And how much attention do we think it would get?
Wow. I mean, I'm sort of inclined to agree with you, I think. I think something like that would set off a brief and impassioned debate that would probably fairly quickly be marginalized by events. So I would probably come down on your side.
Yeah.
But also my fear would be, so if it's not they're coming to get you in a way that's relatively unambiguous, I'm afraid it would feed in to various kinds of pervasive cynicism about the communication of esoteric knowledge to a wider public. And so it would lead the news, and the serious mainstream media outlets would cover it. And then the response of everything surrounding that would be to ask, what's really going on with the interplay between the people in Oxford and the people at the BBC, whatever it was. I mean, I'm afraid that we are at the moment in that kind of information space. And it's always a really interesting question, not, I think, just in relation to space, but other things too. What does and doesn't cut through? It almost goes back to where we started. What's the thing that allows us to say, right, we have now transcended our petty concerns? And Chris, I tend to agree with you that I don't think the thing that you describe would be that, unfortunately.
It'd still be fun,
it would exacerbate some of our pettiness. Yeah. I want to ask one last question, which pull some of these things together. So relatively speaking, if you look at the three things that we've talked about, and one of the challenges is just to think about timeframes for this. When you think about this in terms of potential threats to us as a species or whatever it is. And Chris, earlier on, when you were talking about the chances of asteroids hitting, and you said at the end of the century, and then you corrected yourself to the end of the millennium. And in some ways, that's a big difference, right, for people like us. There's thinking about risk in those terms. Can we take seriously, given everything else that's going on, the risks that come with at least the small but real possibility of Earth-threatening events? Then there are the risks that we associate with the militarization of all of this and the possibility that we're entering a new era of Cold War style political competition, which feeds into space. And then there are probably the newer risks that come with commercialization. So cluttering up the atmosphere with satellites, the possibility that we're going to try and extract minerals from asteroids, and that's as likely to be done by commercial as non-commercial organizations. And we've got to try and sort of get a hierarchy of these risks. Which are the ones that we should be taking most seriously? It feels like the second two outweigh the first. What we should be thinking about are the military commercial risks. But on the other hand, the first is the one that, where we started, has the potential to change everything. My question is, what is the hierarchy of risk here?
Well, I think when you put it like that, you've almost described three different types of risk, which we as a species are good or bad at dealing with. The first, the asteroid, is about discovery. We need to find the things. And then a fairly simple technological solution. We're not talking about inventing the anti-asteroid ray gun here. We're talking about hitting it with something the size of a golf cart, suitably far in advance, right? This is straightforward. We're good at that sort of thing. The second, which was your, the militaristic elements of space. Well, there's a different kind of solution there. We have, Tom knows much more than me, but we have this experience of diplomacy and so on playing out in a new sphere. You can make your own judgment whether we're good at that or not. And then the third one, which is a complex environmental problem involving many actors and a common resource that's being used by many different parties, a mix of commercial. We know we're bad at those things. And so, if we phrase the question differently, you say, if you could click your fingers and remove one of them, somehow, I'm going to solve the third one, because I know that as a species and as a civilization, we are bad at exactly that sort of thing. See climate change, see pollution in the oceans, or whatever example you want to pick. So I think you're right to put attention there, but that doesn't mean that I think there's an easy fix beyond reframing it somehow as a different kind. If we could turn it into something that perhaps diplomacy can attack, or an international regulation. But if you're calling for large international regulation as a solution to an environmental problem, I think we know roughly how that usually ends up. But maybe I'm being too pessimistic.
Tom, you get the last word on this.
Well, I mean, to my mind, the risks that are attendant in space militarization and the politics that go along with it are very clearly more grave than those of any kind of extraterrestrial risk to the Earth itself. I think there's more or less no context between those things. The trouble is, I think that we can't help ourselves. And perhaps that's right. Perhaps that's part of who we are. It's very deep in our culture, space technology, and finding it inextricable from military technology is something that is now with us and will remain with us. It's too deep in our bones. Etymologically speaking, to consider is to observe the stars. A disaster is an ill-starred event. Looking out to space and then using it for our own designs is something that is just inevitably with us.
And on the commercialization, so as it were, you can see the US military behind Elon Musk, or you can see Musk-style projects behind the US military. As it were, you can be cynical both ways. You still think the risks of geopolitical conflict in a nuclear age extending into space, that's the danger over and beyond the ways in which commercial organizations are now muscling in the same arena.
In my view, yes. I mean, that's something that perhaps we haven't sort of gone into in sufficient depth, or at least from all of the angles. But I think so. I mean, it seems to me that the balance of power is sort of still with the state in this domain. SpaceX, as impressive as its PR is still, I think, fundamentally a government contractor in most of the ways that matter. And I think that leads me to believe the risk is still very much on the state and nuclear end of things rather than the commercialization side of things, while recognizing that there's definitely problems on the other end as well. I mean, ideas of some sort of Kessler effect problem with satellites because of commercializations and grabs of that sort are certainly there.
Chris, I just saw you shaking your head. Do you want to have the last word?
Yeah, I think SpaceX is a fascinating topic. We could have talked about that all day. I do think that they've been able to take risk in a way that NASA hasn't, and that's a deliberate decision by the US's to have. But what they've done with rockets, in particular, finally delivering on a promise of reusing rockets. Several of the SpaceX rockets have been to space now 10, 11, 12 times. That's what's made things cheaper, and that's enabled all sorts of things. There's a European Space Agency telescope that's going to tell us about the past, present, and future of the expansion of the universe being launched on a SpaceX rocket this weekend. And that's not because ESA was excited about using SpaceX. They'd rather have used European rockets, but it was cheap and available and right there. And so I do think, while they are a government contractor, I don't think you can quite reduce them to a government entity in the way that Boeing and some of the other large companies have acted in space. What they're doing is enabling access to space, but what they're using it for is mostly their own purposes rather than a shared access to this new frontier or the vast cosmos or whatever you want to think about it.
If you want to hear Chris Lintott talking more about the search for extraterrestrial life, you can see him on next week's episode of The Sky at Night on the BBC. Chris also has his own podcast. It's called Dog Stars, talking about space while walking his dog. You can also read much more by Tom Stevenson about space and about international politics in the LRB. We'll be posting links to that. Next week, it's the third in the current series of History of Ideas. I am going to be talking about Henry Thoreau and his essay on civil disobedience and trying to relate it to civil disobedience today, including Extinction Rebellion. Please join us for that. Please follow Past, Present, Future on Twitter @PPF Ideas. My name is David Runciman, and this has been Past, Present, Future, brought to you in partnership with the London Review of Books.